Subscript F is correct. Yeah, this would be good to know for next Monday. What is V without a vector symbol?
Speed.
Speed.
Now, you could get away with final velocity squared if you somehow, if it's understood that a vector squared is the same as a vector doing a dot product with itself. I flip back and forth on whether that is understood or not, but do remember this is a speed here, and that's a speed. Those are vectors, but these are scalars. All right, so we have 0 is equal to 49 plus 2 times negative 7.9596 times delta x. Do we expect, should we expect delta x to be positive or negative?
Positive.
Because it's going up the ramp and we established that to be the positive direction. So 49 divided by 14, so that's closer to 16, somewhere around 3 meters. 3.3 and change, 3.07. So we take a shot at it, 3.07, 216, 599. It's going to be really impressive if I nail it.
It was, right, you got the acceleration in the formula mixed up, it's 7.9596.
95, oh. Thank you. What?
No, 3.078.
You had 3 point what?
I got 3.078. Wait, 9596.
It's 9596, I
Oh,
switched 2 numbers there.
okay, I didn't switch numbers.
Units?
Meters. No, it's meters.
Yes, it's displacement, it's how far.
It looked at me like I did something wrong. Like I said, like meters are wrong.
It was more of a look of, you said meters so incredibly carefully, like you were unsure, so I was about to question how sure you
Well,
were.
you looked at me and I thought I said meters wrong for a second.
People always misinterpreting my looks. That was my curious look, not the angry look or your wrong look.
I got it.
All right, so we have how far it's going to go up the ramp, answered that part. Now the question, any questions up to there before we talk about whether it's going to come back down? Then let's talk about it's coming back down. So for the return journey, so once it gets up and it stops and then flips around and then wants to come back down, what changes in our force diagram? Yeah. So the only difference is that this is now in that direction. And it's static. Do we want to, so if it's going to accelerate, which way will it accelerate?
Down to the left.
Yeah, that hasn't changed. So, do we want to flip the direction of I5 hat? Or keep it?
say keep it, cause that would make sense, 'cause I mean, we know it's gonna be going down, so we can just say the acceleration is negative.
Alright, so if you go back to this, let's do a different color for the contrast here. So that now becomes positive. That stays the same. That stays the same.
If we did flip the positive axis of I5 hat or I have 5, what would the equations change to? Would everything change?
If we made down the ramp positive, then that becomes positive, that stays negative, that becomes positive, and we're expecting A to be a positive number. So now when we get to here, I would recommend we flip that also, which makes that negative and that positive.
So it's less confusing than the first model was.
It depends on where your mind's working at the time.
Okay.
Yeah, I mean, it's, as long as you acknowledge that I'm gonna expect a negative number for acceleration. we're good. So that's positive, which makes that positive, which makes that positive. So the only thing that has changed over here that's a positive number. So if some calculators, you can just go back in, change that one thing, and you're good to go, and others,
Negative 5.8819.
ooh. One issue here,
Oh, yeah.
that's a 0.4 now. Because we have to see if it's gonna slide back down, so is it gonna overcome the friction, the maximum static?
Quick question.
Yep.
Wouldn't the 5 be canceled out on both ends?
Wouldn't the 5 cancel out with what, that 5?
Yeah, and the other 5.
You can only cancel out common factors, and 5 is not a factor here.
Oh, right.
And also, there's no 5 in that term.
Negative 4.843.
All right, we got a negative answer. Since we said up was positive, and we're expecting it to be a negative acceleration, then yes, it will slide back down, and because of the earlier work, the acceleration down the ramp will be that. So once we establish that it will slide, we go back to point 2. And presumably get Cliff's answer earlier from earlier. Questions? Why don't we come up with some stuff too? I mean, the primary thing is that you've got the test coming up. Say master set 4, 5 concept due on the 28th. And then we get into March 3rd. All right, when is spring break?
Is it the first week of March?
So the 3rd through the 7th?
I thought it started on the 1st.
It is.
That's a Saturday, so it could be.
It's,
Is it the 5th through the 9th?
yeah, it's like. Yeah, 15.
Okay. Alright,
Because
so-
there's technically class on Tuesday.
So, and the master set 4-5 application due on the 3rd.
Wait, we did chapter 5?
4 and 5 together.
What is chapter 5?
I think 5 introduces friction.
Oh,
In Blackboard, I have 4 and 5 lumped together. Because I can never expressly remember which one's 4, which is 5. And I don't want to throw that. Oh, there it is.
28th is a Friday.
Yeah.
28th is a Friday. It's master set 4, 5, wait,
Conception.
4, 5, I broke it into 2 parts. One is conceptual and the other one is application.
Okay.
So the 4, 5, not a lot of numbers in it for the concept. And the 4, 5 application, more numbers.
that's the 3rd of March for the.
Yes, 3rd of March.
Application.
Any questions before we start throwing stuff? Actually, before I start throwing stuff. Well, more specifically, clean stuff.
Are we now doing this in quick updates?
Yes. All right, so I'm now gonna swirl this thing around my head in an attempt not to hit a student. And the question is, if I'm, let's say I'm here. I think I'm going back this way, I'd hit right between the boards. So where do I let go so that I hit as close to that spot as possible? So let's do a incredible map of the room here. We got the 2 boards. I'm standing right here, swinging around like that. And I want to hit that.
Like the,
So let's do it by clock. You know, I should release it at 12 o'clock, that means I'm releasing it there, 3 o'clock, 6 o'clock, 9 o'clock, and so on. If somebody says release it at 12 and someone says 12:01, I cannot differentiate between those 2. I can probably do half-hour increments, but not smaller than that.
Say 2.
2 or 1.
yeah, it's like 1:30.
So we got 1, 1:30, and 2.
I don't think
Anyone
that
else?
would be 2.
Pardon?
I thought it would be closer to 3,
No.
like 2:30.
I think it could be 3.
Oh, 2:30?
Well, like 2 to 3.
All right, so 3 o'clock would be there, so you're going for 2:30 there? That's your,
If you go
Between
3, it
2
would go,
and 3.
it would go straight back, it would go straight back there.
I feel like if it was, because I feel like if it's 1, it's gonna hit more towards like
Because you
the
can't be like standing.
all right, so if I'm standing here, so 3 o'clock, it's being released basically there.
And that would hit like.
I'm saying-
there.
That was it straight.
So,
And
That was straight in
then
front.
there, not like
there?
there.
Sure.
I think that's
That's
about, that's about
two.
1:30 to me.
That's
Okay, 1:30.
1:45,
I would
13
say-
seconds.
That looks more like 2. But,
Just so people can tell us apart.
oh,
So it could be 1:30 to 1:30.
Go 1:30. Anybody want to go for, 6 o'clock or 12 o'clock?
Let's go 9.
Yeah, I'd say 11.
Well, he said like 10:30.
You want to go with 10:30? Is that just to see what happens if I do it there, or that you're serious?
she get like a
Out the
phone ball
door.
instead and actually just throw
That
it.
would hit like.
Wait, are we going clockwise or counterclockwise?
Clockwise.
Noon, 3,
Oh,
6, 9, 12.
okay.
Huh?
What? We changed it?
Did we change it?
No.
Yeah, it was one.
3 o'clock this here, noon, read my mind. 12, 3, 6, 9, 12 again.
And you're spinning counterclockwise.
It's spinning it this way.
Yeah, you would be spinning in counterclockwise.
So let's try 130 first, since that was brought up. So that's 3, so somewhere around here. Now I do have to slow it down for some accuracy. 3, 2, 1.
It was like right in the spot.
It's hard, not rubber.
Yeah, there's a reason I was, I considered the metal mass there tied in a string, and then I thought, yeah, not doing that in case the string breaks. I have never hit a student doing this, just so you know.
It's back here.
It's back here.
By your key.
Oh, there we go. I was doing something similar when the last time I was teaching 7th grade, which I believe is the last time I ever teach 7th grade. And first period, I got closer to Scott than I intended. I released just slightly too late. Scott overreacted, as Scott does. 4th period rolls around, student comes in, Dr. Fox, I heard you hit Scott this morning. I did not hit Scott. I was expecting a call from his parents or something, but his parents were, I think, quite aware of Scott's nature to exaggerate.
Is that the real reason behind why you record classes?
No. No, however, it's a bonus. All right, if I release at 10:30, so where would it go?
I would hit like.
Probably hit Sammy. Just like,
Hit who?
probably just hit Sammy.
Hit 10? So I should have released it there in order to hit that spot?
Or probably noon. I mean, well,
If you release it at 10:30.
If I release it here,
You're hitting like every.
you're hitting like him probably.
Oh, I was just.
No,
I thought you were.
Aaron, I think I'm hitting you.
I thought you were releasing to it that way. I think 12, 10:30. I had it
Cut.
back.
Oh,
Yeah.
Because 10:30 would be that way, right?
it would. It would.
Because your face.
Wow, I'm having real trouble with time today. If I release at 10:30, so if I release it here, I would hit Aaron. So, yeah, she said 10:30, so I would hit probably Tanner or Logan.
Yeah.
Okay.
I mean, it would be Logan because I was up behind him.
Oh, good call. So in general, when you release it, where does it go?
Past where you release it.
Say it again?
Past where you release it.
Around 90 degrees
From,
from the initial starting point, or from the point of release.
okay, tangent, I think is what you're going for. So if I have a circle here, and it's spinning around like that, and I release it at this point, should go at a 90-degree angle there. In other words, it should go tangent to the path. Newton's first law of motion, first law of motion. What is Newton's first law of motion?
An object will keep on going until something else stops it.
More than just, it keeps on going, what will it maintain?
Constant. Constant motion.
Too vague.
Velocity.
Yes, there we go. It'll maintain constant velocity, which means the same direction and same speed. If it does not, there's a force acting on it. Now, once I release it, what is the force acting on it?
Air.
Let's ignore air resistance.
Gravity.
What is the force?
Weight.
Yeah, okay. Again, gravity, huge topic, of which we're studying tiny bits. All right, so the weight is the only force acting on it. What is the direction of that force?
Down.
So there are no forces acting this, I guess, perpendicular to the path, and so it should not stray. Now, therefore, since it's traveling in a circle here, its velocity is not constant. This is while it's still attached to this string and I'm still holding on to the string. Since it's not attached to that, there must be some force pulling it back in. Paraphrasing Godfather 3, every time this mass wants to get out, something just pulls it right back in. And if I did it properly, I'd do an Al Pacino imitation, but my Al Pacino is really, really bad. Can't quite get the sound. So it is being pulled in. The object wants to travel in a straight line, but something keeps pulling it back in. So, of course, there's a name for this. And the generalized this force that wants to pull something back in, and that force is, you sort of faded off at the end there.
It's similar to center.
Is it centrifugal or is it
Centrifugal force.
I don't know how to properly say it.
All right. Now, there's two different pronunciations. One of them makes it sound like there's two words that sound very similar. Another one emphasizes. So it depends on how you just spelled it. I heard centra. I'm good with that.
Centrifugal force.
I did something with it. There it is. And you just said fugal. And what's the other one?
Centrifugal.
Centripetal with a T, no G.
No G.
Centripetal. It's one of those. One of those, it definitely is not. So let's think about what these words mean. Centra,
Center.
yeah. All right, so then I've got this PET and I got FUG. So if you think about FUG, there's a base root of words. Well, we do have words with that same root in it. Fugitive. What does a fugitive do?
Runs away.
So this means center fleeing. This is a force